Welcome to Retro Relix. The Video Genie was a series of computers produced by Hong Kong-based manufacturer EACA during the early 1980s. These computers were compatible with the Tandy TRS-80 Model 1 and as a result were considered a clone. This example is the Video Genie system EG3003 version 2 with the company logo on the left hand side spelling EACA. On the side we have a stylish wood effect which was common at the time, and on the back we've got the power supply unit, the 5-pin DIN external tape drive port, the 5-pin DIN external monitor port, a video cut switch, a 50-pin edge expansion connector and a reset button. On the base we have the details of the system itself, including some of the RF or radio frequency details going through to the TV and Microsoft's Level 2 Basic. Inside we can see the main components of the computer. The CPU board on the left, the interface board on the right, which are connected by these ribbons, and also to the keyboard. On the right we have the RF modulator, which goes out through the back and loops around these two cable storage latches. It has a full stroke keyboard minus the right hand shift key with page and F1 function keys. There's a built-in cassette recorder and power supply unit which is connected to the CPU board. The base of the computer has many grills and one interesting one that looks like room for a speaker. Transferring the contents of the Video Genie system to the workbench, we can see on the CPU board on the left hand side we have a Zilog Z80A CPU chip, followed by 3 operating system ROM chips and 8 1-bit 16 kilobytes RAM chips. On the interface board on the right hand side we have the American Standard Code for Information Interchange character generator, but only 7 1-bit 1K video RAM chips. The power supply is a 240 volt 50 Hz unit with 2 step-down transformers and 3 rather large capacitors and 4 currently unknown voltage pinouts. Checking on the power supply circuit board for voltages drew a blank, but looking at the CPU board we can see there's a +8 and a -15. So looking through the service manual we can see a -15, a +15, a ground and a +8. So we've identified that -15 volts is yellow, +15 volts is green, the ground is black and the +8 volts is red. Which means we don't need the 1980s power supply system that came with the computer. Having sourced a voltage regulator that would deliver both plus and -15 volts, I could couple that up with a multi-channel power supply module to attain the +8 volts. However, I was unable to get this to work, so my only option was to retrofit the existing power supply, and to do that I needed to understand how it worked. So first off, I cut out the existing large capacitors and reversed engineered the power supply unit the circuit board and all of the components. Having tested all of the capacitors, they tended to be around the 20% tolerance mark, which is acceptable, but given their age, it's probably best to replace them. To ensure the safety and future proofing of this unit, I removed the external power cable and replaced it with a kettle socket adapter. As we've already seen, this system has an RF output. However, we're going to use the monitor DIN option based on the rear of the machine. And looking through the user manual, we can see there's a DIN pinout, which is number 4 video output and number 5 ground. And having assembled the cable together, we now have a clean AV output. It's time for the smoke test. Let's turn it on. Okay, we've got something on screen. Pressing new line. It looks like dollars. Yes, it's the ASCII character dollar, where we would expect it to be a space. So looking at the video RAM, we can see it's 7 chips, and we appear to have a rogue bit in position 3. So transposing that chip to position 4, let's try and force a left bracket to test to see if we have a bad RAM chip. So turning the system back on, and yes, it appears to be a left bracket. It is. We've got a bad RAM chip, so let's replace that. Having sourced and installed a replacement 1024-bit RAM chip, let's power it on and see what we've got. That looks great, it's spaces. So let's run a quick Hello World program to test the entire screen. Yep, that looks great. So looking at the internal cassette recorder, having cleaned the heads, we can see via the VU meter that it works. So let's just see if we can load something into memory from the internal cassette. And yes, this basic listing has shown it has loaded successfully. Before we reassemble the system, let's address a few cosmetic issues. On the rear of the power supply unit, I've designed and 3D printed a replacement cap for the hole where the cable used to go. In addition, I've also designed and 3D printed replacement buttons for the video cut and reset switches. Having assembled the video Genie system, it's time to load our first game from the internal cassette. We're going to load Star Wars, so we press play on tape and we correct the VU meter so the needle is in the middle. So let's run this 1977 classic and join R2-D2 and C-3PO. Oh, what is this? Whilst we're here, I'll demonstrate the video cuts button, which displays the first 32 characters of the 64 character screen. You can also press the page button to display the second 32 characters of the 64 character screen. This was used to increase the clarity of retro TV sets with RF. So let's try the external tape recorder DIN port, and using the leads supplied, let's load something from an external cassette into memory. So we type in the cload command, which is slightly different to the internal cassette interface, and we press play on tape, and once loaded we run it. And this is a basic program I've written to simulate a road which ends when it narrows to a certain point. Although system modifications were available, the general way you would load a system or machine language game was via the internal cassette. So to alleviate this issue, I've dug out my old car audio cassette adapter and plugged it into my internet-enabled computer. And having downloaded PlayCAS and a few TRS-80 compatible games, which I'll showcase to you now.